Okay, question 12. We want to multiply these two things together. These are called unlike radicals. What would make them like radicals? Can you name me two radicals that you think are what we would call like radicals? I'll give you an example, but let's use polynomials. Okay, 2x and 5x. Those are like terms, right? 2x and 5x. Can you give me an example that would be like radicals? 2 what?
2 radical 5 and radical 5.
2 radical 5 and 1 radical 5. Those are like radicals. These are not like radicals. Radical 5 and radical 7 are not like radicals. You can't add them together, but you can multiply them. When we multiply them, we're basically putting the product under 1 radical. And what would that be? Radical 35. Before you go reaching for a calculator to try to give me some nasty decimal, I don't want it. Yeah, I know you can type square root 35. You know, you can get the decimal approximation. You all know that it's close to 5 or close to 6, right? Because radical 36 would be 6. So we know it's close to 6. I don't really care what it is. What I will ask you to do is simplify if possible. What do I mean by that? Well, there's a couple different ways to do this. I'll show you what I think is the easy way to do it. And if you don't like that way, then I'll show you a different way that we can try to do it. We need to look for perfect squares. 4, 9, 16, 25. Where am I getting these numbers from? Does anybody know where I'm getting these numbers from? They're perfect squares. All I'm doing is 2 squared, 3 squared, 4 squared, 5 squared, and so on. What I need you to do is look in that list of numbers, and hopefully you've written that list of numbers down so that when you're taking the test and you need to refer back to perfect squares, you can look at these notes and you can find a list of perfect squares so that you don't have to repeat that. Can you find any of those numbers that go into 35 evenly? Any of those numbers that go into 35 evenly? Anything? Any of those numbers going to 35 evenly? Why are you struggling? Because what? What's the reason? Why are you struggling? There are no numbers in that list that go into 35. Social anxiety? No, that's, yeah. Folks, the reason you knew from the beginning that that wouldn't work is that you had a 5 and a 7, and both of those are prime numbers. Now, maybe you saw that, maybe you didn't. I don't know. But none of those numbers goes into, this is the answer to the question. It doesn't get any simpler than that one. Now, when we say things like 25, what that tells me is we're not thinking evenly. You know? That's the kicker on simplifying radicals, is you have to find something that goes in evenly. We are going to skip 13 for now, jump down to 14. Yeah, I know, you'll have to turn the page. Any of those numbers go into 63? You got that list written down somewhere up there. Any of those numbers go into 63. 9 does how many times? 7 times. Now, what I want you to realize, this question isn't done, by the way, but what I want you to realize is that we broke this thing up into what I call perfect squares and then leftovers. Whoa, that's bad looking. Let's try that again. I've got a question for you, and at first this is going to seem really weird, but some of you know my personality, and it won't be a surprise to you. Have you committed any felonies recently? Any felonies? I mean that you're willing to talk about. All right, probably not, right? You probably wouldn't be here if you did. You got a clean record? Suppose you have a family member or relative who is currently being incarcerated. You want to go visit, right?
No. It's not the one I want.
So you go to the prison, right? And you visit. Do they get to keep you there? No. You haven't done anything wrong. You're an innocent person. You're visiting, right? You can't keep a perfect square trapped inside of a radical. You can't do it. This is you, right? With a good record. See, you were just visiting. Right? But now you get to go home. Your relative? Yes, they have to stay. Trapped inside. Okay, answer the final question here. What is the square root of 9? And what's my final answer? 3 radical 7. You are correct. Just remember, perfect squares can't be trapped inside. Nor can you. All right, so let's think about this. Can you think of any numbers that go into 150? Any of those perfect squares, which go into 150? 50 goes in 3 times, but 50 is not in that list. Oh, 15 and 10. You know what? We can break it up into 15 and 10, but guess what? Neither of those numbers is in the list of perfect squares. So we can break numbers up in a lot of different ways, but we really need a perfect square from that list. I'm not going to get ridiculous with the size of the values that I'm choosing. Okay, so what's the largest perfect square you can think of? 25. Now remember, it has to go in evenly, so even though 100 goes in, it doesn't go in evenly. 25 goes in how many times? 6. So what's my final answer? 5 radical 6. Okay, now, I'm not a huge fan of factor trees, but if you don't like either of the methods, the method I just showed you where you look for the largest perfect square which goes into that value. Suppose you don't like that and you want a different way, I'll show you what they showed me when I was in school. It's called upside down division. Now, I'm not a big fan of factor trees because people lose things in factor trees. Not always, but they do. So, upside down division takes the original number, and what I need to do is I need to start with the smallest prime number I can think of that goes into 63. And it's not 2, folks. 2 doesn't go into 63 because it's odd. Do you know if 3 goes into it? Okay. Let's. Didn't we talk about the divisibility rule for 3 yesterday? No, we didn't. Okay. So that's something you might want to remember. If you don't know if 3 goes into a number, add all the digits together. So what do 6 and 3 add up to? 9. Is that divisible by 3?
Yes.
Oh, thanks. All right. Yeah, it is. Therefore, 3 will go into 63. You can do that with any number that you want to figure out if 3 goes into it quickly. How many times does 3 go into, well, can't write a 3. How many times does 3 go into 63? 21 times. Does 3 go into 21? How many times? 7. What I need you to do is look on the outside and find pairs of factors. And where do you think that 3 goes? Oh, on the outside, right. And where do you think everything else goes? On the inside. We'll do that again with the 150. 2 does go into 150 because it's an even number. How many times does 2 go into it? Cut it in half, folks. $1.50. If we cut $1.50 in half, how much will we have? 0? What? 75 cents. Okay. 2 does not go into 75. Does 3? Does 3 go into 75? 7 plus 5 is 12. So, yep, 3 does. How many times? 25 times. Okay, 3 does not go into 25, but 5 does. How many times does 5 go in? 5 times. Every time you end with a prime number, you're done. So, let's find the pairs. There's a pair. And that goes on the outside. Everything else goes on the inside. 2 times 3 is 6. If you like upside down division and you want to use that, I mean, that's what they taught me how to do when I was in middle school. If you want to use the largest, it's obviously faster if you know your perfect squares and you can just look and find the largest one that goes in, pull it apart, and simplify it. Show your work. Everybody needs to show their work because some of you have a real tendency to, on a question like this, skip the step that I want you to show me. Show me that you're breaking it apart into those 2 pieces and that you're simplifying it to here. Okay. Now, perfect squares and leftovers. What's the largest perfect square you can think of that goes into 32? Okay, does 4 go into 32? Yes. How many times? You bring up a very good point. No, I understand. You're right about that too. We can do this. But what did you leave trapped inside? You left another perfect square trapped inside. There's a 4 trapped inside here again. He corrected himself. He said, oh, we could do 16. That's true. But if you don't realize that, it is okay to do 1 step at a time. If you pull out that 4 and then go, oh, I see another 4, I can pull that out again. It's okay. But if you do see that 16 is the largest perfect square, you can do that. Now, what's the index that's right here? What is the number that's on the outside? It's a 2. Does 2 go into 1? Because now we got to deal with the x's. Does 2 go into that exponent 1? No, it doesn't. Which means it is a leftover. It is not a perfect square. So what's my final answer here? Four radical 2x. Okay. We need to really pay attention here because we're now jumping into a different group of numbers. We are no longer dealing with perfect squares. What are we dealing with? Perfect cubes. What is 2 times 2 times 2? That would be 2 to the third. That's 8, isn't it? Right? 2 times 2 times 2. How about 3 to the third? 3 times 3 times 3. 27. How about 4 to the third? 4 times 4 times 4. 5 cubed? That's 5 to the fourth. Good try. Went too high. 125. 6 to the third, 216. Do you see that those numbers are growing quickly? A lot quicker than the perfect squares were. Do any of those numbers go into 32? 8 does. So when I break this 32 up, I've got 8 with 4 trapped inside. What is the cube root of 8? What is this part? That is 2. Let me write down the most common incorrect answer to this question. I'll do it in green over here. What happened for the person that wrote their answer in green? They forgot the index. Well, they forgot the index. What did they change it from? It's no longer a cube root. What did they change it to? Well, a square root, didn't they? Will they lose credit? Yeah, they will. You can't just drop the index if it's supposed to be there. Now, on the other questions where we didn't have an index, we know it's a 2. We don't have to write it again. But when it's a cube root or a fourth root or a fifth root, yeah, you better. So don't just drop the... Now take a look at these two questions. Both of them involve 32. What's the significant difference between them? The index, right? One's a square root, one's a cube root. It is critical that you pay attention to that index. Otherwise, are you looking for perfect squares or are you looking for perfect cubes? Do you know how many people are looking at this question right here and they do 16 and 2? That's another common mistake. And in their mind, they're thinking about perfect squares. They haven't paid attention to we switched gears. We're now in perfect cubes, not perfect squares. So be careful on that. All right, question 18, I'm going to let you do on your own. I would suggest you start by checking to see if 1,000 is a perfect cube. Because if it's a perfect cube, that makes my life really a lot easier. I'd use a calculator if you don't know the answer off the top of your head. Find out if 1,000 is a perfect cube. If it is, that'll be nice for you. sometimes I wonder. Mm-hmm. It is perfect. All right, I love the first part. Not quite the second. So does 3 go into 3? So when it comes out, it's a radical. What? Oh, you're telling me. What you got up here?
Nothing.
Why didn't you take a key root of your time? What you did? Okay, good. And what do you do with the X's?
She has the answer. She's doubting herself.
Mm-hmm. What'd you get for the cube root of 1,000? 10. Now, what I have seen people doing today is this. If you've already taken the cube root, there is no need to take the cube root again. Okay? By taking the cube root of 1,000, it's being pulled outside that radical. Now, does that 3 go into that 3? Does it go in evenly? It sure does. How many times? So my final answer is 10x. 10x, right? Because it's x to the first. Okay, I got a hint for you here on number 19. We're back to cubes, perfect cubes and leftovers. My hint to you goes back to the graphing we did yesterday. So when we graphed these cubes, or like y equals x cubed, we had a shape that looked like that. And then we talked about a horizontal line that went through the graph. Let's say we were talking about negative 32. How many times does the blue line touch the green? One time, right? So what that means to me is that when you simplify this, you're going to take the negative out with the perfect part. So start thinking about what perfect cubes you can use with 32. Might want to look at the previous problem, but let's see what you can do with that. Don't think I would use 16 and 2 if you were thinking about it. Remember, we're dealing with cube roots, so we need perfect cubes. Look at your list of perfect cubes.
Oh.
Yeah. Okay, what'd you pull out with the negative? What'd you pull out? 8. That leaves 4 trapped on the inside. Okay, now let's deal with the x's and the y's. So we've got x to the first. Does 3 go into 1 evenly? No, that means that x is trapped on the inside and cannot come out. Does 3 go into 3? Yeah, so that does come out. So you have to just simplify this part right here in that green box. What is the cube root of negative 8? Negative 2, right? And then 3 goes into 3 how many times? 1 time? What's wrong with my answer? I forgot my index, didn't I? Okay, don't forget the index. Any questions on that? We pulled out the perfect cubes. Everything else was left inside. When you multiply those together, what do you get? Cube root of 22. Is there any perfect cube you can think of? 8, 27, 64. No? Okay. Yeah, you're right. You're right. That's it, folks. There's nothing you can do with that. There's no perfect cube to pull out of it. Just like the very first question I asked you with square roots. Show me what you get on this. Leftover x's have to be trapped inside. So what's the index on the outside right here? Yeah. Like here has an index of 4. That's a 4th group. What's the index right there? When we don't write one in, we know it is. So 2. Another way to look at this is how many times does 2 go into 2? Not perfect. It won't go in perfectly. You're right. But you were in that. But how many times does 2 go into 15? I did it there, so I had to say 4. Okay, there's 2 different ways to look at this question. One, we can look at breaking it up into perfect squares and leftovers. There's another way, and I mean, it just depends on what you like, how you like to look at it. I don't really care which way you like to look at it, but, and this would be one of those questions where you could use one method and not really show work, and I'd be okay with that. That'll work too. If you broke it up into perfects and leftovers, you could take that 15 and break it up into 14 with 1 left over. What's this thing right here in the red? X to what power? The 7th, right? And then, of course, you've got the square root of X. You've got the leftover. Now, another thing you could do is you could do this. 2 goes into 15 7 times with 1 left over. That's another way to look at the same question. Okay, question 22. Before we begin question 22, I just want to write down a few of the perfect fourths. 2 to the 4th. What is 2 times 2 times 2 times 2? 16. How about 3 to the 4th? 4 to the 4th? See, now we're getting larger quickly. That might be useful to you. Multiply them together. Any of you that have ever played with a standard deck of cards probably know what you've got here. So multiply together. Cards in a standard deck? 52. Not including jokers, right? Exactly. How did I look at that question and know we were dealing with 52? How many suits are in a standard deck of cards? 4. And how many cards are in each suit? 13. Okay. Can you simplify that any? No, thank you very much. None of those numbers, 1681 or 256, go into this, so it is finished. Go to question 23. Show me what you can do with 23. Multiply them together first. Perfect squares which go into 7. Saw several of you put it together and you got 70xy like this under the radical. Are there any perfect squares out of your list of perfect squares? Your 4, 9, 16, 25. Any of these numbers go into 70? Any? What? Say it. No, that is correct. Okay, so the 70 is trapped inside. What about the x and the y? Also trapped inside. Thank you very much. Done with the question. They don't always simplify, folks. We look for ways to simplify, but they don't always simplify. Okay, 24. Now we're dealing with perfect fifths. Okay, just to write out a few perfect fifths, like 2 to the 5th. That's 32, right? Whoa, gotta freeze it. 2 to the 5th is 32. 3 to the 5th. Ooh, 243. Man, we're getting big quickly. Don't think you'll have to worry about 4 to the 5th. See what happens if you multiply and see if you can simplify that. When you combine them together, let's see what you got. Yep. Combine them together. Yeah. X to the well, that's a 2, that's a 1. So 2 plus 1 gives me. Right, so we have 10x cubed underneath that radical. Make sure it's a 2. Yeah. Power up there. What's the 5th root, right?
That's how I feel things.
Yeah. Make sure I know this might seem picky, but it's yours looks like it's so efficient, not a little.
This is.
I know that sounds picky, but it does mean something different. Now the question is, are there any perfect fifths inside there? But so far, our perfect fifths are 32, 243. Either of those numbers go into 10? No. Does 5 go into 3? No, they're done. Okay. Hopefully, when you put it together, you ended up with the 5th root of what? 10 x cubed. Now, do you have any perfect fifths that go into 10? No. Does 3 go into, or does 5 go into 3? Nope. Done. Thank you for your hard work today.